Gamma-ray bursts are the strongest and brightest explosions in the universe, which are believed to be generated during the formation of black holes. Although gamma-ray bursts last only a few seconds, they produce as much energy as the Sun emits in all 10 billion years of its existence. Mysterious phenomena were first discovered in 1967 by a US Air Force satellite called Vela. According to NASA, the probe was designed to observe secret Soviet nuclear tests, but in the end he discovered dazzling gamma rays, the most powerful electromagnetic radiation that came to us from outside the solar system. When such an event occurred, it briefly became the brightest object of gamma radiation in the observable universe. Only in 1991 did astronomers launch the Compton Gamma Observatory, which recorded about 1 new burst of gamma radiation per day. The BATS tool found that gamma-ray bursts were distributed evenly across the sky, which means that they occur everywhere in space. BATS also showed that there are two types of gamma-ray bursts with different signatures, those that lasted from 2 to 30 seconds, and those that blinked for less than 2 seconds. Since then, researchers have learned much more about gamma-ray bursts by developing a network of quick-response satellites and ground-based observatories that all target a gamma-ray burst as soon as it is detected. This network provided data showing that gamma-ray bursts are located in galaxies at a distance of billions of light-years and that after the initial gamma-ray burst, the flash source produces afterglow at less energetic wavelengths. Where do gamma-ray bursts come from? It has been found that longer-lived versions of gamma-ray bursts are associated with superpower supernovae called hypernovae, which occur when stars 5 to 10 times the mass of our Sun end their lives and turn into black holes. Hypernova stars are 100 times brighter than typical supernovae and are believed to be formed from stars that spin especially fast or have a particularly strong magnetic field that gives extra energy. But the short-term gamma-ray bursts, which make up 30% of such events, remained a mystery until 2005, mainly because they are too fast and fleeting for subsequent observations. After NASA launched the Swift Observatory in 2004, it was finally able to record enough data to see the afterglow of short-lived gamma-ray bursts and find out that they were probably sent from two superdense neutron stars that collided and formed a black hole, or when a black hole ate a neutron-out star. Such flashes are so strong that they create ripples in the fabric of space-time, called gravitational waves. Now that the researchers have launched the Laser Interferometric Gravitational Wave Observatory, LIGO, which can detect gravitational waves from these collisions, we can collect even more information about the processes that underlie short-lived gamma-ray bursts. There is still much unknown about gamma-ray bursts. Recent observations have shown that all photons emitted by gamma-ray bursts oscillate in the same direction, but for some reason the direction changes with time. What it can be, we really don't know, said after opening in 2019, Merlin Cole, a scientist from the University of Geneva in Switzerland and one of the leading researchers. Gamma-ray bursts also seem to focus their energy in a narrow beam, rather than emitted equally in all directions, which means that our satellites miss many of them. According to astronomers, although the satellites detect about 1 gamma-ray burst per day, but about 500 occur in a day. Until now, gamma-ray bursts have been detected only in distant galaxies. However, it is possible that this will happen in our galaxy, the Milky Way. Extinction in the Ordovician period, one of the 5 major extinction events in the history of our planet, occurred about 450 million years ago and could be caused by the ice age caused by a gamma-ray burst. If a new gamma-ray burst occurred near the Earth, it would deprive us of the protective ozone layer and would subject its entire life to deadly ultraviolet radiation. Thus, scientists agree that they are not observing bursts in our home galaxy.